We are going to continue our lesson with mole conversions, but now we're doing conversions between moles and mass. So when you hear moles and mass, I want you to just go ahead and automatically think about molar mass. Molar mass is a concept that we learned. I went over it in another video, and it allows us to convert between moles of a substance and mass of that same substance. So our first example, you have a 55 gram sample of aluminum. How many moles of aluminum are in the sample? So we're just going to start this off like we do every other mole conversion problem with dimensional analysis. So given is our 55 gram sample, and don't forget to write the substance, so 55 grams of aluminum, and I want to know how many moles of aluminum that is. So I've already told you that to go between grams and moles, we need to think about molar mass. So that means I need to go to the periodic table, and this is just aluminum, so it's just one single Al atom. So aluminum is 26.98 grams per mole. We can go ahead and round that to 27. That's pretty safe. So our conversion factor is that 1 mole of aluminum equals 27 grams of aluminum. Now, molar mass will be different for every single substance. So whenever we're doing problems where we're looking at moles and mass, we're always going to have different conversion factors. Let's go ahead and set up our dimensional analysis. 55 grams of aluminum. Okay, now I have to do what? Bring my units diagonally down. Yes, good job. Way to go. Grams of aluminum, and I want to convert to moles, and I can go straight to moles using this conversion factor here. So 27 grams, 1 mole. And because grams are in the numerator and the denominator, they cancel out. I am left with moles of aluminum, which is what I wanted to solve for in the beginning. And so I do 55 divided by 27, and I get 2.043 sig figs, because I had 3 here, moles of aluminum as my answer. Okay. Next problem. A certain reaction produced 8.0 moles of carbon dioxide. How many grams of carbon dioxide were produced? So first of all, we need to make sure we know what carbon dioxide is. So carbon, single carbon, dioxide, 2 oxygens, that is CO2. You have to know that in order to be able to do the rest of the problem. We're given that we have 8 moles of CO2, and we want to know what the mass of that is. And this problem is nice. It actually says how many grams. But if instead it had said what mass of carbon dioxide, we would still know that we're looking for grams. Mass is pretty much always in grams unless the problem specifically asks for something different like kilograms. So our conversion factor here is still going to be similar to the last one, but it's not going to be the exact same number. So here we're going to say that 1 mole equals the molar mass of CO2. So we have to go to our periodic table, find carbon is 12. We have 1 of those plus 2 oxygens, so 12 plus 16 plus 16. And that gives us a grand total of 44 grams. Be more specific. 1 mole of CO2 equals 44 grams of CO2. That is the molar mass. So we're going to write down our given, 8.0 moles of CO2. Draw your little T-chart thingy. Units, moles of CO2. Come down here. And we can put grams on top. 1 mole, 44 grams. So moles of CO2 in the numerator and the denominator cancels. 8 times 44, and we get, comes out to be like a little over 350, but we can only have 2 sig figs, so I have to round it. I think it's like 352, but I wrote down the exact answer. So 350 grams of CO2. And that has 2 sig figs, just like this had 2 sig figs. So that's how you do mole conversions from moles to mass and mass to moles.